Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ayuni binti KAMRI, metric number DF210071. For the first presenter, I want to present about executive summary for this project. Executive summary for this project is about selected bridge we want to do for this project. The selected bridge for this project is the Brigde Truss Bridge at Truss County, Kansas. This is picture of this bridge. Now I want to explain about this bridge. Firstly, about dimension. Dimension this bridge length is 140.1 feet, a height 16 feet, pavement design 140 feet per way. Secondly, I want to explain about this project. Have a 3 point. Firstly, to examine the internal force and deflection of the proposed bridge. Second, to compare and discuss the internal force and deflection obtained by these two methods, such as using manually and using software. Third is to discuss the structural integrity of this bridge in terms of safety. Thirdly, I want to explain about analysis bridge. For analysis bridge, we using manually and software such as LinPro. We can see no difference between manual calculation and LinPro calculation. Next, I want to present about introduction this project. Introduction this project have 3 points. Firstly, about truss. Truss is a structure made up of cylinder member in a triangle shape. The joint links are created by bolting or welding a structure made of weights. For truss, the load supporting truss is because of tensile and compressive force in the member. This truss have two types, rough truss and bridge truss. For rough truss have such as Howe truss, Pratt truss and Warren truss. For bridge truss such as Warren truss, Howe truss and Baltimore truss. Secondly, I want to explain about Pratt bridge. Pratt bridge truss was patented in 1944 by Thomas and Caleb Pratt. The Pratt Truss bridge design is a low-cost structure, is easy to assemble with unskilled labor, has a low insertion cost and is simple to transport, can be utilized in a variance design circumstance and can be altered to reduce the span to dip ratio. The Pratt bridge can fail if poorly designed, resulting in high maintenance costs. Visually, the Pratt Truss bridge is not as assembling as different truss designs, but this is subjective. Thirdly, I want to explain about LinPro. LinPro is the software being used for analysis structure. LinPro is a straightforward program for static and dynamic frame analysis. Static analysis is a program that supports variance load and is extremely versatile in structure creation. It contains almost all the tools required for linear static analysis of plane frame. Framing, design simplification, material saving and pre-release are all important consideration for this proposal. That's all for me. I pass this presentation to the next presenter. Thank you.
Hello, my name is Brigde. In this video, I'll present about layout and design, loading and assumption, and calculation using software for our structural analysis group project. The bridge that we refer to is this Cotton Wood River Park Truss Bridge at Chase Country, Kansas. The dimension of this existing bridge is shown here. So, from that existing bridge, we do a little bit change to produce the new design for truss bridge for our group project. We can notice that the top chord and the bottom chord length is 5.35 meters, the vertical members length is 4.88 meters, and the diagonal members is connected within the joint. Okay, now we want to calculate the determinacy of this truss. The formula is M plus R equal to 2J, which is statically determinate truss. So we calculate the number of members M first. The M is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. The number of member is 29. The number of reaction R is at joint 0 here. It is a roller support, so it only has vertical reaction, and joint at it is spin support, which have the vertical reaction and also the horizontal reaction. So the total number of reaction is 3. R is equal to 3. And next is number of joint. Number of joint is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. The number of joint is 16. So M plus R is equal to 29 plus 3, which will get 32. 2 times J is 2 times 16, which will get 32 also. So we can conclude that M plus R is equal to 2J, and this truss is statically determinate. So the degree of determinacy is M plus R minus 2J, which is 32 minus 32. 32 minus 32, and we'll get the answer of 0. The degree of determinacy is 0, and this truss is ethically determinate truss. Now, here is the loading and assumption for our group project for this truss bridge. So we assume it has two loads, which is live load and dead load. For the live load, we assume only one heavy vertical loading with a value of 356 kN at joint 4, which is at the center and the bottom part of this whole truss bridge, and a dead load, which is the self weight with a value of 880.1 kN, which is distributed equally at the bottom chord from joint 0 here until joint 8, with the value of 90.9 kN downward as a point load at each joint from joint 0, 1, 2, 3, but at joint 4 we need to add up with this value 356. So here is all the loading that we assume, and for the area that we assume for each member is 3250 millimeter square. The E value is 200 megapascal. And we assume this truss bridge is in static truss analysis for the further LINPRO calculation. Okay, so here is the interface for LINPRO software. We can click the Run Static Analysis button here to generate the results. We can see the moment diagram, shear force diagram, and shear force diagram, deflection line, and reaction. So we collect all the data in the report as shown here. So here are the diagrams results that generate from LINPRO software, and here is the member force value that we get from the LINPRO, and we also attach the output result from LINPRO for all the members and the criteria that analyzed by the software. I think that's all from me. Thank you.
Assalamualaikum and hi, my name is SURAYA binti KASSIM. In this part, I will explain about the manual calculation that we use to solve and find the deflection occur at the middle of the bridge truss, which located at joint 4. First step is to find the internal and external forces for each member. Virtual work method was being used to solve this problem. So, first thing to do is find the real forces. For finding the real forces, I tend to use alternative method because it is more simple and easy to calculate, also easy to detect if there are any mistakes. After balancing and get all the forces, next is to calculate the virtual forces, which means there are replacement occur at one joint which is located at joint 4, also applied with 1 kN. Repeat the step to find the internal and external forces, but in this time, based on 1 kN that been applied just now. The next step is record both data, virtual forces and real forces into the table, including area, length, and other related information. The table are very helpful because all the information being used to calculate the deflection occurs at joint 4. So here we can see the value of deflection occurs at joint 4 after being calculated. When we compare all the value of forces and deflection value when using LINPRO and manual calculation, we can see the difference, but not too much because as we know, LINPRO does not use the zero force member rules, but only on calculation method. That is why there are differences occur on every value. That is all from me. Thank you.
Assalamualaikum and hi, my name is SYAFIQAH RAHMAN and I will explain the discussion part for our group. A truss provides a stable form capable of supporting significant external load over a very long span because a triangle cannot be distorted by the stress. Our group is building a bridge with a dimension of 42.8 meter length, 4.88 height and 5.21 width. A truss design, the comparison between LINPRO software and data and manual calculation show the reaction on support and internal forces. There is slightly different occurs during the process of manual calculation as it includes zero force member to balance the internal forces. However, we still could use both result from LINPRO and manual calculation for the operation purpose by choosing one of them. As for the integrity of our truss bridge design in terms of safety, this design of truss bridge is statically determinate. Structure and structural member must always be designed to carry some reserve load in addition to the normal load. The rules has been emphasized in our project as we take consideration while doing the calculation to ensure the balance and ability of the bridge. When a load is applied, internal forces develop along structural members as tension and compression forces. Tension members are pulled or stretched, whereas compression members are pushed or shortened. The tensile and compressive strength of a material are determined by its composition. Design of truss bridge can be volatile, but the main important is to make sure the base is strong enough to bear the mass. Good maintenance start with good design. Hence, this project carried out by proposing modification resulting for stable truss design as we showed in the balance of internal forces and limitation of deflection. Our group decided to simplest modification design of truss bridge while considering the importance of strength and stability to hold loads.